We're going to look at the determinant of a matrix. Now, when we're finding a determinant, this is referring to a scalar value of a square matrix. So it has to be a square one, same number of rows and columns. So we can't just do any old matrix. It must be a square matrix, such as 2 by 2, 3 by 3, so on and so forth. It's got to be a square, so same number of rows and columns. Okay. Now, we're finding what we call a scalar value. It's just a value, so the determinant is going to be something like 15, -7, just some value. We use determinants for a number of things. In this part, we're just going to actually compute that determinant value. So the first thing we're going to look at is a 2 by 2. So when we're looking at some 2 by 2 matrix, I'm just going to call it A, B, C, D. So A, B, C, and D just represent some numbers. When we want to find a determinant, it's going to be A times D minus B times C. So basically, I'm looking at this, and I'm going to take these two. So I'm thinking I'm going down this way, down to the right, minus, and then come back and pick up the other two. So we're going to come back the other way. So it's always a minus in the middle. We're going to multiply, subtract, multiply, regardless of what the signs are. And so we're going from the top left down, top right down. Let's get some numbers in here. 3, 7, 2, 4. Okay. So I'm going to go 3 times 4, so we're going to go down. 3 times 4, minus, coming back, 7 times 2. So let's see, 12 minus 14 is -2 is my determinant value. Okay. Let's go -3, 2, -1, -4. So it doesn't matter what the signs are in there. We're still going to work with moving down and then minus coming back the other way. Okay. So we're going to start with 3 times 4. Excuse me, -3 times -4. So I've got -3 times -4, then minus 2 times -1. So I have a positive 12 minus a -2. That's going to give me that positive 14. Let's look at a couple more here with these 2 by 2s. I'm just trying to mix the signs up a little bit. Sometimes the signs are what throw us. So we're still going to look at going down. So I always think this way, minus, coming back the other way. Okay. So we're going to have 2 times -2 minus -4 times -3. Always that minus or subtraction in the middle. And then we're just watching our signs here. So we'd have -4 minus, and then that would be a positive 12 because -4 times -3 is positive 12. So -4 minus 12, -16. Okay. So again, we want to get locked in our minds. Down, minus, coming back. Okay. So let's throw an X in here and kind of look at what happens. All right. And then we'll move to that 3 by 3 one. So I'm going to say solve for X. Okay. So I'm saying the determinant X, 7, 2, 5 equals -3. So the determinant of this 2 by 2 matrix equals a -3 value. So I'm just going to evaluate the left side of the equation. In other words, just write out the determinant. So we're going to have X times 5. That would be 5X. So I went down, minus, coming back. 7 times 2 is 14. Equals -3, and there's my equation. So I end up with a two-step equation, not too bad to solve there. Add my 14 over. 5x is 11. And so then x would be 11/5. Let's look at one more like that. I'll just move the x around. We'll go 7, x, -3, -4, and we'll say equals 20. So we're going to start with that 7 times the -4, and then minus coming back down the other way. So 7 times -4 is -28, minus -3x equals 20. So now I'd have -28 plus 3x, minus a negative, and then I'm ready to finish out the solving. 3x would be 48. I'm going to send that 28 to the other side. X would then be 16 for my value at x. So again, we want to remember this piece right here. We're going to go down, minus coming back. So we're going to take a look at a 3 by 3 here, but we want to keep that same idea. We're going to move down from top left, moving down, minus coming back the other way. Notice 2 elements, minus the product of 2 elements. So let's look at how a 3 by 3 kind of looks. We can actually use that same concept of down to the right and then coming back to the left. 2 elements minus the product of 2 other elements. So I'm just going to get a 3 by 3 up here. Some different numbers in there. All right, so I've got a 3 by 3, 3 rows, 3 columns, 2, -1, 4, 1, 2, -3, and then 3, 2, 5. Now, if I picture what I was talking about, moving from the top left down to the right, basically that would mean we're going to take these guys right here, multiply them together, those 3, so top left, down to the right, notice 3 elements, minus coming back the other way, 4, 2, 3, still 3 elements. The problem is what's happening there is I have not incorporated this -1, -3, 1, or 2. Incorporate those. So here's a trick that you can use. Rewrite the first 2 columns. Rewrite the first 2 columns. So I've rewritten just this 2, 1, 3, -1, 2, 2 over on the outside there. Right? So now here's what we're going to do. I'll come back and put the numbers in. We're going to go down. So 2, 2, 5. Down. -1, -3, 3. Down. 4, 1, 2. Notice 3 elements, 3 elements, 3 elements. Minus. Then we're going to come back. -1, 1, 5. Minus. Coming back again. 2, -3, 2. And then minus. Coming back again. 4, 2, 3. So it's still moving down to the right. Minus coming back to the left. I'm going to come back and we're going to work this problem, but just to kind of show you, instead of just talking through it, I'm just rewriting it down here. So this would be all of the elements. I've got my 3 columns and the 2 that I rewrote. Okay. So what we're going to do is start on the top left. We're going to multiply those. Then we're going to multiply with that -1 going down. Then we're going to multiply with the 4 going down. 3 elements. Notice 2, 2, there's not a third element here. So this is where we start coming back. So I'm going to go on this right side. We're going to pack those 3 elements. Then coming back, those 3 elements. And then coming back, those 3 elements. Okay? And at first glance, when you look at it like that, it's like, well, wait a minute, you left the 1 and the 2 out. I didn't leave this 1 out because it got incorporated over here when I rewrote it. And the same with this 2, it's sitting right in here for that piece. So basically the red, since it's moving down to the right, plus, plus, plus. The green, minus, minus, minus. That's our pattern that we're going to do. Right? So I'll just leave that there. We can kind of follow those pieces. And I'll write the answer up here. All right, so we're going to move this first one down. So I'm going to go 2 times 5 is 20 plus -1 times -3 times 3 is 9 plus, again following that red one, 4 times 1 times 2 is 8. And then here comes the minus each of the greens. So -1 times 5 is minus a -5. 2 times -3 times 2 is -12, so minus a -12. And then our last one, minus 4 times 2 times 3. Or if you look at this green, 4 times 2 times 3. So that's 8 times 3, 24. Now, I know that minus a negative is a positive, but usually I'll write it like this so that I remember it was plus, 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 minus, minus, minus. Okay? So I remember if I'm looking at the reds, if I'm coming down this way, we're adding. If I'm going back the other way, I'm subtracting. If one of these had ended up being negative, I'd have it in parentheses with those pluses out there. Now it's just simplifying the values. So let's see, that would be 29, that's 37. Let's see, plus 5, plus 12, minus 24. So that would be, let's see, 42, 54, 30, and unless I did my math wrong, but you get the idea, we're just combining those like terms. So our first step is always going to be to rewrite the first 2 columns. If you're drawing the circles all the time, sometimes it kind of gets confusing. It's nice here with the red and the green because you can kind of follow, hey, I did the red ones, and I came back and subtract the green ones. Some students find it easier kind of doing this. They'll go this way, this way, this way, and they'll draw arrows coming back on those top 3. So this guy's getting used twice. Sometimes that helps. But you've got to keep your eye on what you're multiplying or which 3. Of course, if you need to, and you draw the circles, but I would suggest using different colors like I did, because then you can kind of keep track of what's going with what. Okay, so let's change our values here. So a new 3 by 3 matrix. We're going to go 2, 0, -5, -2, 1, 4. I'm just trying to keep some of the numbers small. 3, -1, 2. So there's my 3 by 3. And it's always going to be nice for us when we have a 0 sitting in there, because if we multiply by 0, we get 0. So that kind of helps us out a little bit. So our first order of business, rewrite the first 2 columns. Now the nice thing about rewriting the first 2 columns, it keeps you moving diagonally just like you did for the 2 by 2. I'm going to start here at this 2, going diagonally, then the -2 diagonally, then the 3 diagonally, all plus. So here we've got 2 times 1 times 2, 4 plus, that would be 2 plus -10. So notice I'm still writing plus, then the -10. Again, to remind me that I'm adding as I'm moving down. And then plus 0. 3 times 0 times 4 is 0. So now minus, for this negative 2 coming back. Minus, and that's a 0, so I've got a 0 sitting there. Minus 2 times 4 times negative 1 is negative 8. Minus 3 times 1 is 3 times negative 5, negative 15. So there's my setup. After that, it's just combining the values. So I'd have negative 6 here. Let's see, gone. Plus 8 plus 15. So 17. I think the actual mathematics as far as the computation, it's pretty simple. Multiplying three numbers, add, subtract. Not much going on there. But definitely does look confusing sometimes when you've got all the numbers jumbled up there. That I do understand. So make sure you're getting that pattern down. All right. Let's look at one other one. And then we're going to throw an X in there. All right, so let's get another example. Let's go negative 2, negative 1, negative 3, 5, 0, 1, negative 2, 4, 2. So there's our 3 by 3. So our first option is going to be rewrite those, our first course of action, rewrite the first two columns. So we're going to have negative 2, 5, negative 2, negative 1, 0, 4. I get those rewritten. Now we're going to move diagonally. So I'm looking at negative 2, going down, then negative 1, going down, then negative 3, going down, all plus. So I would have, that would be 0. So I have a 0 there, plus 2, plus, let's see, that's 20 plus negative 60. Now we have minus, coming back for 3. Minus negative 10, multiply those 3. Minus negative 8, minus 0. 0 here. Okay. Now we get our terms combined. The zeros aren't going to matter. Let's see, this right here would be negative 58 plus 10 plus 8. So negative 40 be the value of my determinant. Okay. Now let's take a look at one more of these 3 by 3s, and I'm going to change it to like we had before with the 2 by 2. I'm going to put an X in here. So here's my 3 by 3. 2x 5, negative 3, 2, negative 1, 1, 4, negative 2. There's my 3 by 3. X in that top middle. Doesn't matter to me where it is. So what we're going to say again is solve for X. We saw on the 2 by 2. And I'm going to say the determinant equals 6. So we're trying to solve and figure out what X value is going to make this determinant value a 6. So I know it's equal to 6, but what I'm first going to do is evaluate the determinant that's on the left side. So I'm going to rewrite those first two columns again. So I'm going to come down here, 2, negative 3, 1. I'm just rewriting my 3 by 3. And then I'm going to so there's my, you can put the brackets down here or not. I'm just writing the columns. Now I'm going to rewrite the first two columns. 2x, negative 3, 2, 1, and 4. There's those first two columns. So now this is the part I'm going to evaluate. So the same thing we were just doing. I know there's an X in two spots, but it's not going to change how we're doing the process. We're still going to look going down and then minus coming back. Nothing changing on that. So we're going to have 2 times negative 2. We have negative 8 plus negative x plus, and let's see, that would be negative 60. Minus coming back. Minus negative 2 times negative 3 is 6. So minus 6x minus negative 8 minus 5 times 2 times 1, 10. Now I know this equation equals 6. Now I'm solving the equation. All right, so I did have a couple of x's. When it rewrote, I got an x in 2 spots, but it's still not changing how I evaluate that overall determinant. So let's get some things combined here. Let's see, that'd be negative 7x. Combine my x's. Let's see, negative 8 and positive 8 cancel, so we've got negative 70 equals 6, and there's my two-step equation. I'll add my 70 over. 76. X would be negative 76 sevenths would be the value of x that would create the determinant value of 6. Hopefully I didn't make a mistake there in my arithmetic, but you've got the idea. It looks really bad with the x's in there, but when we combine like terms, we just have an equation to solve. All right, continuing with our determinants, we're going to look at solving systems. We're talking about systems of linear equations using Cramer's rule. Now, Cramer's rule is just one application of determinants. So we computed a determinant. We determined, hey, the determinant's some scalar value. You know, like we get a 7, it's a 7, whatever the value is. So Cramer's rule actually is an application of determinants in order to be able to find or solve for x, y, z, whatever. So I wrote the base rules up here. X, d subscript of x, and we'll talk about that over d. Y, d subscript of y over d. Z, d subscript of z over d. Whatever variable we're solving for. If we're solving for a in a system, it would be d subscript of a over d. Okay. Now, I've got here to the right, d cannot be 0. Okay, so obviously d can't be 0 because then you would be dividing by 0. Right? So if the d value is 0, this process would not work. All right. Now the d is what we call the base determinant of the system. The base determinant. We always want to find the base determinant first, because if that ends up being 0, then we're not going to continue the process because I can't solve it using Cramer's rule. I need to make sure that that's not 0. So here we'll look at a 2x2 system. 2x2 systems are generally the fastest, just simply because the determinants of 2x2s are quicker than 3x3s. We saw that. Let's go 5x minus y equals 4. Okay, so there's my 2x2 system. Okay. So we're just looking at it, solving doing Cramer's rule. There's other ways to solve a 2x2 system. This is going to be just reflecting Cramer's rule, one application of using determinants. My base determinant, the base determinant d, is the x and y columns. So I have an x column, a y column. There's my base determinant. Again, x column, y column. 2, 5, 3, negative 1. Now this I'll evaluate. This would be negative 2 minus 15. So just like we were doing before, negative 2 minus coming back 15. So negative 17. That base determinant is not 0, so I'm going to continue forward. All right, so there's my d value, so that's what I'm going to have in here on these fractions. D with a subscript of x. D with a subscript of x. When I see this subscript here, d sub x, that means the answers, 6 and 4, replace the x column. Answers in x. The y, 3, negative 1, does not change. So d sub x, answers in the x column. Then I evaluate the determinant. Negative 6 minus 12 is negative 18. Next, d sub y. If I see a subscript of y, the answer 6, 4 now go in the y column. So whatever variable's here, that's where the answers are going. And then the other column does not change, so I'm rewriting my x. I'll evaluate my 2 by 2 determinant. 8 minus 30. 8 minus coming back, minus 30 would be negative 22. There's my d sub y. So I've got my values for d, d subscript of x, d subscript of y. So this means that x in this situation would be negative 18 over negative 17, or just 18/17, since the two negatives cancel. So there's my x value, d subscript of x over d. My y value, negative 22 over negative 17, or 22/17. There's my y value. A little bit longer process than some of the algebra ones, but again, just working a different process for solving our system. So I want to find d first, d subscript of x, d subscript of y, and then I can set up my fractions. Let's look at a different one, 2 by 2, and then we'll look real quick at a 3 by 3. Okay, so a different setup. Let's go x plus 2y equals negative 6. 3x minus 5y equals 1. Solving this system, I'm going to find d, d sub x, d sub y. D, base determinant, 1, 2 up top, 3, negative 5 on the bottom. Again, x column, y column. Negative 5, minus 6, negative 11. Not 0, so I'm good to go. D sub x. X right there. That means answers. Negative 6, 1. Replace the x column. Y does not change. So now I would have 30 minus 2 is 28. D subscript of y. Answers. Replace the y column. So negative 6 and 1 in that y column. Evaluate. 1 minus negative 18 is 19, and then I'm set up to go find x and y. So x would be d sub x, 28 over d negative 11. D sub y for the y, 19 over negative 11. There's my x and y values. So the key is just setting up whatever we're going to evaluate for determinants and then go through that process. Now let's look at a 3 by 3, right? 3 by 3 system. Now we've evaluated some 3 by 3 determinants, and they are definitely a lot longer, more involved, something like that. So let's get one up here. Let's go x plus 2y plus 3z is 1. 2x minus z is 2. And let's go 4x plus y plus z is negative 1. So there's my 3 by 3 system. I know I don't have a y there in the second row, but that just means that coefficient is 0. So we could write in a plus 0y if it helped us, but there's my 3 by 3 system. And what we're going to do, let's use Cramer's rule. So we're going to do Cramer's rule to find, and let's just go with z. We're going to find z. Okay? instead of finding all three, we're going to find z. We still have to find the base determinant and then the d sub z. So we'll need these two guys. So I'm going to go find that base determinant first. So that base determinant d. 1, 2, 3. So remember, that's just the x, y, and z columns. 2, 0, -1, 4, 1, 1. All right, and so then evaluating my 3 by 3, remember we rewrite the first two columns. 1, 2, 4, 2, 0, 1. So I'm spending my time evaluating this d. So now I go down 0 plus -8 plus 6 minus 4 minus -1 minus 0. So let's see, this would give me -2 minus 4 is -6 plus 1 is -5. There's my d value. So I'm looking for z, which means I need d subscriptive z over d. So I know what d is, -5. Now I'm going to go find that d sub z. All right, so the subscript. That means the answers replace that column. So the answers of 1, 2, and -1. So the answers, what's on the right side of the equal sign, are replacing the z column, x column, 1, 2, 4, and y column, 2, 0, 1, do not change. And then I'm going through and evaluating that determinant. So I'm rewriting my first two columns. Then we go through the process. 0 plus 16 plus 2 minus -4 minus 2 minus 0. Evaluate. See, 18 plus 4 is 22 minus 2 is 20. So d sub z is 20. So my z value would be 20 over -5, which is -4. Right? Now the 3 by 3s do become pretty cumbersome in using Cramer's rule because you have a lot to go through and evaluate. I mean, in this case, I shortened it up. Instead of finding x, y, and z, we just found z. But that tells me I need my base determinant, d sub z. If I had said find y, well, I still need the base determinant. And then remember, the answers would replace the y column. And same idea with finding that x. Okay? For those pieces there.